Hello everyone, this is Akshmala and today in this video I will take you through solution of AIET 6 class 12 G paper. Okay, so I've selected questions based on difficulty level and based on where I felt like that I felt like that question has concepts within so much. So those questions I have picked up and we will go through those questions. So let's start. Let's navigate through it. So the very first question is the very first question of your paper. Let's read the question first very carefully. There is a totally reflecting a small plane mirror. Okay, there is a plane mirror like this, and it is kept horizontally. Now, this is not attached to anything. So if it is not falling down, it is getting supported by some upward force for sure. And here the mass of mirror is given as 20 gram. So it will have gravitational force acting downward, mg. Now assume that there is no absorption in the lens. There is a source of light S here. And whatever light is coming out from this source is allowed to go through or pass through a convex lens here. Done. But this lens is not absorbing any light. Done. It is not responsible for that. Now, 30% of light emitted by the source goes through the lens. Since you can see here, light will also go on like this. Only 30% is able to pass through the lens. So only 30% is able to fall on the mirror. Now, find the power of source needed to support the weight of mirror. So what should be the power of force? Sorry, power of source so that it will exert whatever light is falling on the mirror will exert that amount of force which will be required to support the weight of mirror. Now, if you have not read this concept, you may be getting confused like how light will exert pressure, force and all. So light exert force because light has a momentum. We have studied that if there is a light of wavelength lambda, suppose, then it has a momentum. It has a momentum. How much? Momentum, if you say P, momentum is equal to what? Is equal to energy of light, that is hc by lambda by c, h by lambda. So the momentum of light is equal to E by c, where E is the energy of light and c is the speed of light in that medium. Okay, so this is the momentum. Now, while we discuss the momentum of light, we consider it as a particle. So light is made of photons. We have studied in particle nature of light, and each photon will have momentum of E by c because each photon has an energy of E, and they are moving with forward velocity v. Sorry, c in the media, which is vacuum here. So E by c is the momentum. And if this photon will strike on certain surface, it will its momentum will get affected. There will be change in momentum, and so force will get exerted. So let's first see how force will act here, like what amount of force. So this is the mirror, like right. This is your plane mirror, and let's take any one light. So one light is falling like this. What will happen to this light? This is falling at an angle 90 degree, that is along the normal. So light will reflect back like this. It will retrace, simple. So this is going to happen. Now let's talk about momentum change of single photon first. So suppose I'm assuming there is a single photon that is striking the surface. So before striking the surface, initial momentum of photon you will take as E by c. Its velocity direction is in this sense. And the same photon after reflection will travel like this. So its momentum after reflection, that is P final, will become minus E by c. Done. And change in momentum we will write as 2E by c. Now the case is not only single photon will fall on the plane mirrors. There are so many photons falling. And how we will calculate that how many number of photon is falling? Because for single number of photon, change in momentum is this. Done. So if we somehow are able to reach at a point where we can see how many photon is falling per second, then we can calculate how much change of momentum per second. And that is force, right? So there is a source here. There is a source here. Suppose from here, whatever light is coming out has a power P. Yani ki it is generating, it is releasing energy P per unit time. Done. And not all the light is falling on the mirror. Then how much light is falling on the mirror? 30% of it. So if power is P, then 0.3 P amount of light, energy of light is falling on the mirror per unit time. So this much energy per unit time. Done. So number of photon, if you see number of photons per unit time, you will write as what? Number of photon per unit time, how much? So we will see in this energy how much photon is contained. So one photon means E energy. If we divide this total energy by E, that is energy of single photon, we will get number of photon per unit time falling on the mirror. So that is equal to 0.3 P by E. So this is total number of photon falling per unit time. So total change in momentum, if I calculate delta P total per unit time will be equal to how much? For single photon, change in momentum is this. And for whole number of photon falling per unit time, it will be this. So this is equal to 0.6 P by C. And this force should balance the weight of this mirror. And weight of this mirror is in downward direction, mg. Done. So this should be now equate and calculate the value. So mg 20 gram, 20 into 10 to the power minus 3 into 10. And this is equal to 6 into 10 to the power minus 1 into P by 3 into 10 to the power 8. So 3 say 2 times, 2 say 10 times. And if you see here, this will become 10 to the power minus 1 and here it is. So all will get cut like this. And power is 10 to the power 8 watt, joule per second. So we can write it like 100 megawatt. Megawatt means 100 into 10 to the power 6 watt. Then that is 10 to the power 8 watt. So answer will be what? Answer will be what? This. So this is the logic, okay? And this is very helpful, I hope. This will be your answer. Now let's move on to question number 3 that was given. Is actually not in your syllabus because we don't have to read characteristic X-rays, okay? So we don't have to read it for G means. So let's not discuss it for now. Now, let's come to question number 6, and this is from your NCERT. None. So here, rectangular loop of side 10 centimeter, 5 centimeter current, carrying current of 12 ampere in place, is in different orientation is given, right? We have to say that in which diagram the configuration is in stable equilibrium and configuration is in unstable equilibrium. So if current is passing through a loop and it's placed in a magnetic field, and we have to talk about stability, then we will consider potential energy formula. That is minus m dot b. M is magnetic moment and b is magnetic field. Okay. Why potential energy we are considering? Because when we talk about stability, we talk about energy. Then the body which has less and less of energy, that will be more stable. And body that has high and high of energy will be more unstable. Okay. So just try to see in which configuration this will be minimum. Okay, that will be stable. And in which configuration this is maximum, that will be unstable. Okay. So this is minus mb cos theta, where theta is angle between m and b. M is your what? Magnetic moment, I into A. And A is a area vector. Area vector हम कैसे निकालते हैं? Just curl your finger in the direction of current and towards towards whatever direction your thumb is pointing, that is the direction of area vector. Okay. So in first diagram, if I see the current is going like this and area vector is along this. So in first diagram, area vector is along x axis, है ना? And magnetic field is along z. And magnetic field is along z. So x and z के बीच का angle होगा 90 degree and here potential energy is what? 0. Let's see if it is minimum or not, because in some case energy may be negative. Then, and in second case, if you see, curl your finger in the direction of current. So this is this. Area vector is along minus y axis. Okay. So area vector is along minus y axis. And magnetic field is along what? Z. Again, angle is what? 90 degree. So potential energy here also is 0. Now come to the second case. In second case, you can see here, area vector is along, curl your finger along the direction of flow of current. Area vector is along Z. So area vector is along Z. And also magnetic field is along Z. So angle between area vector and magnetic field, yani ki magnetic moment and magnetic field is what? 0. So if this angle is 0, then potential energy will become how much? This will become minus MB. And come to this graph, the same configuration only with current direction being opposite here. So if you see, current is flowing in this sense, area vector is in this sense, that is minus Z. So area vector along minus Z and magnetic field along Z. So angle between area vector and magnetic field is 180 degree, that is between M and B. Potential energy will be minus MB cos 180. Cos 180 is minus 1. So this will become MB. So potential energy is maximum here and minimum here. So second is your most stable, then because energy is minimum, and fourth one is your most unstable. Done. So correct answer will be what? Correct answer will be your A. Okay. Chalo. Now this is the question. Again, question is very much easy here. Three capacitor A, B, C, and they are connected to 25-volt thing. Ratio of charges on capacitor A, B, and C. So just see here, B and C are in what? Parallel. And in parallel, we add capacitor like series. So the diagram will become something like this. This is your 5 microfarad, 5 microfarad. And this is your 12 plus 8, 20 microfarad, done. And this is this. And this is how much? 25 volt. Now, if you are going to solve it, these two are in series. So C equivalent will get added like parallel, 20 into 5 by 25. So this is 4 microfarad. So equivalent capacitance here, if we talk about, this is how much? This is equal to 4 microfarad. And here potential value is 25 volt. So total charge that this battery will release, total charge Q will be equal to C equivalent into V, and that is equal to how much? That is equal to 25 into 4. So this is 100 microcoulomb. Okay. So from here 100 microcoulomb is coming. So across 5 microfarad capacitor, charge will be QA will be 100 microcoulomb. And on this 20 microfarad also, total charge will be 100 microcoulomb. So here 100 microcoulomb charge is coming, and that will get divided into this and this. So this and this are in parallel. So for that, just you calculate here potential difference across 20 microfarad. Charge on it is 100 microcoulomb. So Q equal to क्या लिखते हो? CV. V equal to what? Q by C. So 100 by 20. And that is equal to 5 volt. So potential difference across 20 microfarad is 5 volt. So across it is 5, and across it is 5. Now across it, charge will become 8 into 5. That is QB will be 40 microcoulomb and QC will be your what? 60 microcoulomb. Take the ratio, right? So 100 is to 40 is to 60. If you're going to take it, first it will become 10 is to 4 is to 6. And then it will become 5 is to 2 is to 3. So correct option will be what? A. Done. Chalo. Now let's move on to this question. In a diffraction pattern due to single slit of width A, first minima is observed at an angle of 30 degrees. Just see here, this is a diffraction case. And in diffraction case, we know that for minima, A sine theta is equal to what? N lambda. And first minima will be for n equal to 1 and so on. Done. And for maxima, we have seen here, for maxima, what we see? So here A sine theta should be equal to 2n plus 1 lambda by 2, and first secondary maxima, that is avoiding central maxima. So first secondary maxima will start for n equal to 1. Now let's go on to the question. First minima is observed at an angle of 30 degrees. So let's solve it for first minima. So A sine 30, first minimum is A n equal to 1, so lambda. Now if you see here, sine 30 equal to what? Half. So A equal to 2 lambda. From first equation we got this. Now wavelength of light is given, and this is the first secondary maxima is observed at an angle of. So suppose कर लो theta angle पे मिल रहा है. So A sin theta will be equal to 3 lambda by 2. A का value आप put कर दो. This is 2 lambda sin theta equal to 3 lambda by 2. So lambda will get cancelled and sin theta is equal to 3 by 4. So theta will be sin inverse 3 by 4. This is this thing. Okay. So these are formula based questions, simple. But you remember that for minima condition is this, and n will not start from 0, n will start from 1. And here also, this is condition for maxima, just opposite of interference. And here also, n will not start from 0, it will start from 1, 2, 3 like that. Okay. So this was important thing here. Mark it. Okay, we got answer D. Is it correct now? Chalo. Okay. Let's move ahead. There is a bubble in glass slab. So let's make a glass slab here. And this is the glass slab. Suppose it is resting like this and its thickness is D. Now what is happening? When viewed from one side of apparatus, when viewed from one side appears at 5 centimeter. So there is a bubble in the glass slab. Suppose Carlo, I'm saying this is the bubble. So when viewed from this side, this bubble appears at a height of 5 centimeter. So from this side, let's say H apparent is equal to how much? 5 centimeter. And from this side, when viewed, H apparent is equal to how much? It is 2 centimeter. So these are apparent height of bubble from two sides. We won't say 5 plus 2, 7 centimeter is the width of slab. No, because these are apparent heights given, okay, of the bubble inside. Then thickness of the slab is what? So let's say refractive index is mu, thickness of the slab is D. So for first bubble, let's say real H apparent इतना मिला, really bubble must be somewhere. ठीक है, मैंने apparent height को ऐसे दिखा दिया, but ये real लाइन मैंने ड्रॉ किया है. सो अभी के लिए इसको मिटा दो. What from here to here real height, let's say this is x. Okay, so from here to here real height of bubble will be how much? D minus x. And for this observer, if I go on to calculate apparent height of this bubble for this observer 1, if I say, so h real, that is x, by h apparent, that is we don't know, that is given 5 centimeter for this 5 centimeter and for this 2 centimeter suppose. So real by apparent equal to, कैसे मैंने बताया था तुम लोगों को क्लास में, how you will write it. So you just need to see light is traveling from where to where. So here is the bubble, observer is here. Light always travels from object to observer. So light will travel from slab to the air. Then, and here we will write refractive index. Light is traveling from slab to air. So refractive index of slab divided by refractive index of air. So real by apparent height equal to, just see light is traveling from where to where. जहां से light चलना start हुआ है, write refractive index of that media on the top, and then at the bottom write refractive index of media to which light is traveling. Okay? So this is this. Now x by 5 will be equal to mu. X is equal to 5 mu. Okay. Second case के लिए अगर आप solve करोगे, so real height here is d minus x, and the apparent height given is 2, and this will also be equal to mu because here also object is inside the slab, observer is in the air. So d minus x is equal to 2 mu, x is 5 mu, so d is 7 mu, and 7 into 1.5, and that is equal to 10.5 centimeter. Okay. So correct answer will be C. Okay, now let's solve this question. 28 gram of nitrogen gas is contained in a flask at a pressure of 10 atmosphere. Okay. And at a temperature of 57 degrees. So pressure, initial pressure given is 10 atm. temperature given is 57 degree. Convert it into Kelvin because while we use equation PV equal to nRT, we always keep T in Kelvin. Okay. So what you will do, 273 plus 57 Kelvin. And if you are going to solve it, it will become this 0, this is 3, this is 3. So 330 Kelvin is the temperature. Okay. Now it is found that due to leakage in the flask, now this was the initial case. After leakage, what is happening? So let's write things very clearly, neatly, okay? So after leakage in the flask, pressure is getting reduced to half. So pressure is 5 atm and temperature is getting reduced to 27 Kelvin. That is 273 plus 27 and Kelvin, that is equal to 300 Kelvin, okay? This the quantity of empty gas that leaked out is. So what is the amount of nitrogen gas that leaked out? So if you want to see here, what is initial number of moles of nitrogen present? Let's see. So PV equal to nRT if you will apply here. Pressure is equal to how much? 10 atmosphere. This is SI unit because 1 atm is equal to 1.01 into 10 to the power 5 Pascal, which is SI unit of pressure. So 1.01, we can take that as 1. Done. So, okay. So, अगर इसको SI unit में convert करना है ना, so you will write here 10 into 10 to the power 5 Pascal. Done. But without converting here, I will go because on another side here, because we are not going to add these two equations, we are going to simply divide and divide. Yes, so I'm going to simply deal with division thing. So whatever in whatever unit you are taking, it won't matter because here also pressure is in ATM, here also pressure is in ATM, they will get cut. So no point of converting. So I'm not converting here. But ideally, if you have to calculate exact value of n out of this equation, you need to convert. Okay. So 10 into volume को V मान लो by R into 330. And this is equal to N. So if you see here, uh, N is equal to how much? N is, or you say, चलो मैं इसको N1 बुलाती हूँ, ठीक है? So if you see here, V by R is equal to 33 N1. Okay, let's use the same equation here. PV equal to nRT. So P का value is 5. Volume will remain the same. Gas is leaking, but container volume is not going to change, right? So 5 into, because that is contained in a flask. This is not balloon kind of thing. If gas is leaking out, its volume will reduce. No, it's a flask. So volume will remain the same. 5V, that is PV by R. R is constant, temperature is 300 into N2. So if you see here carefully, N2 is equal to how much? N2 is equal to 5V by, okay, 5 by 300, that is your 1 by 60 into V by R. So V by R को क्या लिख सकते हो? 33 by, okay, 33 N1. Done. So this is equal to this. Clear है? Now, if we are going to solve it, N2 is equal to this much N1. And leakage mole, amount of mole getting leaked, if I'm going to calculate, it will become equal to N1 minus N2. Okay? So, N1 minus N2. And N2 value is how much? 33 by 60 N1. 33 by 60 N1. Okay? So, let's calculate it more. So let's see how much amount of mole is getting laid. So this is equal to how much? We can break it here also. 20 and this will become 11. So N1 minus 11 N1 by 20, that is 9 by 20 N1. N1 value is already given, right? 28 gram of N2 was present. We have to calculate how much mass got leaked. Okay. So if we need to calculate mass of it, then simply mass of it leaked will be equal to how much? 9 by 20 into N1 into mass, sorry, N1 in terms of mass, like this is the amount of mole initially present of nitrogen gas. And if we are converting whole thing into mass, so we will take here what? मास ऑफ नाइट्रोजन प्रेजेंट, जैसे N1 की जगह आप यहाँ पे क्या लिखोगे? इफ यू आर गेटिंग कंफ्यूज्ड आई कैन राइट इट, जैसे 9/20 N1 को आप क्या लिखोगे? मास बाय मोलर मास, डन. एंड इफ यू आर गोइंग टू कन्वर्ट इट इनटू मास, so how we convert mole into mass? We multiply it with molar mass. So again here you will multiply with what? Molar mass. So mm will get cut, small m will remain, so small m means 24 gram. Done. So answer will be how much? It will become 12, 9 by 20 I have written. And this is, if you're going to see it, what should be the thing? Let's see here. Okay, more we can cut it. 5 से cut कर दो 6 times से. So this is 63/5 gram. Okay, so cut to the level you can, and after that you will get the answer. So answer is 63/5 gram. Okay, chalo. So let's do now this question. So three rods of material X and three rods of material Y are connected as shown in the figure. All are identical in length and cross-sectional area. End A is maintained at a temperature of 60 degree. Okay, and E at a temperature of 10 degree. Thermal conductivity of X. So X value is given. X is equal to 0.92 and Y is that of 0.46 in proper units given. Okay. Find the temperature of junction BCD. So B, C, and D. So we already know that when heat current is going through a conducting rod, then heat current, that is heat flowing per unit time, we write as Ka delta T, that is temperature difference between its end divided by L. And we term it like delta T, that is temperature difference, same as potential difference, analogy, L by K, and that is treated like resistance. So potential difference by resistance, that is equal to heat current. Okay. And here if you see AB geometries of all the rods are same. So whatever resistance will be for AB, same resistance will be for BD and DE. And similarly, whatever resistance is of BC, same will be for CE because both have same thermal conductivity also. Okay. And if you look at it through the lens of electricity, you can see here this whole structure is the Wheatstone bridge. And here this resistance of BC by resistance of BD, that is, let's say resistance of AB is R, then resistance of BD will be R, D will be R. Let's say resistance of BC is R dash, then this will be R dash. So R dash by R equal to R dash by R. So this is a balanced Wheatstone bridge. It means no current will flow through, no heat current. So C and D have same potential. Now let's see if some options we can filter from this thing only. In option A, C and D has different potential. This is wrong option. Here both are same, may be correct. Here both are different, wrong. And here both are again same, so may be correct. So we have to filter between B and D. So let's calculate the potential of point B. Now let's first see what is the resistance of R. So R value can be written as L by K, and that is for Y. Y value is 0.468. Okay? And R dash, if you write, it will be L by 0.928. So if you see carefully, what is relation between R and R dash? So R dash is simply half of R. Done. So R is equal to what? R is equal to R dash by, yeah, R dash into 2. Here we will write like that. So if we multiply it with 2, it will become equal to R, right? So R dash and R has a relation, this relation. Why? Because for calculation, we will use it. Now let's draw it like this. So resistance of wire AB, that is R, and this is point B, and here this is point E. Done. And what will be the resistance between B and E? So this is R dash plus R dash. So that is your what? R dash, I have taken this, right? So R dash plus R dash will be 2R dash, and this R plus R will become 2R, and these two are in parallel. So let's calculate equivalent RBE. Okay, so this will be equal to how much? 2R dash को हम क्या लिख सकते हैं? Like R is equal to 2R dash. Done. So R dash can be written as what? R by 2. So this became r dash को आप convert कर दो r by 2 से. So this will become 2r dash will be equal to r. So r equivalent r into 2r by 3r. ठीक है. So this is equal to this. Now resistance along it is equal to 2r 2r into r, that is 2 by 3r. And if we go on to see, current flowing between arm A and B will be same as between B and E. They are in series. So let's write the value of heat current now. So delta T between A and B, that is 60 minus T by R, will be equal to what? This is RBE. So temperature difference you will write here, T minus 10 divided by RBE value is how much? That is 2R by 3. Okay. So if we go on to do this, 120 minus 2t will be equal to, sorry, r is here, so r will get cut, equal to how much? 3t minus 30. And this will become 5t equal to 150. So t is equal to 30 degrees centigrade. So correct answer will be what? This one. B is correct. Okay. Now let's move on. Okay, so this is another question. The given curve represents the variation of temperature as a function of volume for 1 mole of an ideal gas. Which of the curve best represent the variation of pressure? So T versus V curve is given. We have to identify for this curve, PV curve will be like what? Done. So T curve can be here. This is a straight line curve. Its slope is tan 45. So M slope value is 1, tan 45 is 1. Now let's say this is T naught. So y-intercept is T naught. If I go on to write the equation, T will be equal to how much? MV, that is 1 into V plus y-intercept, that is T naught. Means I'm writing it in a standard form. Y is equal to mx plus C. C value is T naught, M value is 1, Y is T, X is B. So this is this. We have to convert it into pressure volume thing. So already volume we are having, temperature we need to remove. So temperature को volume के term में लिख दो. How you will write that? So use ideal gas equation, PV equal to nRT. So T can be written as PV by nR. And here number of mole is 1. 1 mole is given in the question. So PV by R is equal to V plus T naught. And if you go on to calculate it, PV equal to RV plus RT naught. And if further we do, PV minus RV is equal to RT naught. And here you see P minus R, V equal to RT naught. So this is Y along Y axis, this is along X axis. So Y minus R X is equal to RT naught. So this is the equation of hyperbola, right? And here the curve of hyperbola is this. So correct answer will be A. Chalo. Now let's do this question. Consider a solid SP of radius r and mass density is this. The minimum density of the liquid in which it will float. Done. So we have to make it float. And what should be the minimum density of liquid in which float? What is the condition of floating? Now we see that if there is a liquid and if liquid has a higher density, or in the opposite way you can think, if object is light enough, very light, like imagine leaves falling on the water surface, it floats like a cream, like just it goes on to float, very magnificently does glide over the surface. And if you take an empty bottle, plastic bottle, so plastic bottle, when you will throw into ocean or sea, that we should not do, but we do, and you must have seen what it will float without even little getting submerged inside. So it will float like its bottom surface is almost on the surface and rest is up in the air. But if you take a metallic ball or a metallic bottle, so if it is floating, you will see that some of its part is immersed in the water. Done. So if you see more heavier object floating, it will have some of its part submerged in the water. And how much heavy you can take until you want it to float. Then how much heavy you can afford on the condition that you want it to float still. So floating के लिए maximum density that you can afford is such that its whole of the part will be submerged, its whole part will be submerged, and it won't sink to the bottom, it is still floating, but whole of its volume is submerged. That high density we can take at least, or at max. Done. And if density increase by that value, beyond that value, then this body will not float, it will sink. So there is a maximum limit of density for any object to keep floating in a liquid. Done. And here density is given as this, the minimum density of a liquid in which it will float. So for minimum density of liquid, it will float such that its all of its portion will be almost submerged. Okay, for minimum density of liquid. Then if density, like what I explained taking example of density of object into account, but you can think in the opposite way also. If density of liquid is heavier, it will allow less part of body to get submerged to let it flow, right? कम से कम बॉडी का पार्ट डूबा रहेगा तो भी वो फ्लोट कर सकता है, क्योंकि इस लिक्विड का डेंसिटी ज्यादा है, वो बॉइंट फोर्स थोड़े से सबमर्शन के लिए भी ज्यादा लगाएगा, so body will keep on floating. Done. So for minimum density of liquid, what we will consider that the body has all of its portion immersed in the fluid. Done. So what volume of liquid will get displaced in this case? The volume equal to the volume of body. So let's say there is a sphere of this, its radius is given as r. So its volume will be equal to how much? 4 by 3 pi r cube. So whole of its volume is submerged for minimum density of liquid to help it float. Done. So this is the volume. So buoyant force अगर आपको निकालना है, force of buoyancy, it will be equal to what? V immersed rho of liquid into G. And that is equal to how much? 4 by 3 pi r cube into rho L into G. And this force of buoyancy acting in the upward direction should be equal to force of gravity acting on the body in downward direction. So let's calculate Fg. Then we will equate Fg to Fb and we will calculate rho L. Now, for calculating Fg, we need to calculate the mass of the body. And here density is not constant, it's variable. So see here, suppose this is a sphere and at any radius r, first we are taking a strip of this sphere of thickness dr, suppose. So its volume of this little sphere will be how much? Volume of that little thickness. Volume of sphere contained in thickness dr of this spherical cell will be how much? So volume, small volume will be equal to 4 pi r square dr. Surface area into thickness. Okay? So mass of this will be equal to how much? Small mass dm. So this element has been taken at radius r. So at radius r, density is equal to this much. So put the value rho naught 1 minus r square by r square like this. This is the density. So density into volume. And that is 4 pi r square dr. Now, in order to calculate the total mass, what we will do? We will integrate. Okay, so integrate. dm m will be equal to constant term को आप बाहर ले लो, rho naught 4 pi. ठीक है, and this will become equal to how much? This will become equal to r square minus r4 by r square का this whole का dr, and r will vary from 0 to r. So if you are going to calculate it, rho naught into 4 pi and its different integration r square का होगा r cube by 3 and its integration will be r5 by 5 and r square was there. So this is this limit 0 से r. So if you're going to see the values, rho naught 4 pi, this is r cube by 3 minus r5 by 5. If you're going to calculate it further, here there was r square. ठीक है, so ये r cube हो जाएगा. r cube को आप क्या कर सकते हो? Here you can see this will become r cube. इसको common ले लो. So rho naught 4 pi r cube and this is 1 by 3 minus 1 by 5, so that is equal to 2 by 15. So this is the mass, done. And this force of buoyancy we need to equate to what? Mg. So Fb will be equal to mg. Now Fb value is how much? 4 by 3 pi uh, rq into rho L into G, and this is equal to mg. M is rho naught into 4 pi rq into 2 by 15. This is mg. So G will get cancelled. 4 pi you can cancel, and from 3 it will get cancelled by 5 times. So RQ will get cancelled. So rho L is equal to how much? 2 by 5 rho naught. Only the trickier part here is ki what portion of body you will consider as immersed for liquid density to be minimum. So if liquid density is less, more and more of body's portion need to get immersed to keep floating. Okay, done. So that was the thing. Now let's see this question. Consider a sphere of radius r. A sphere of radius r is here that carries a uniform charge density rho. If the sphere of radius r by 2 is carved out as shown, then the ratio EA by EB of magnitude of electric field EA and EB at points A and B due to remaining portion is this much, x by 17. Then what will be the value of x? So for remaining portion, there was a sphere initially, complete a sphere of radius r having charge of density rho. What we did, we took one cavity of radius r by 2 out. So no charge is present in this region. And then it is asking what will be the electric field at A and B. So question is, like I have discussed in electrostat, that if you have to uh, solve questions of cavity, just imagine that just say initially it was having positive charge everywhere and now it is a cavity having no charge. So we can imagine that it has same density of negative charge. This thing, like if we have a sphere, big sphere of density of charge rho inside, so everywhere positive charge is there. And if there is a cavity, और cavity भूल जाओ अभी, suppose कर लो I am keeping here another small sphere and this sphere has a uniform charge density of minus rho and that is kept inside that region. So what will happen? Net density here will become rho minus rho, that is 0. So this is cavity. Done. So cavity we can treat like it has charge density of opposite nature of same magnitude. Done. So we can consider here like we are having two spheres, big and a small one. So R is sphere. A sphere of radius R has a charge density rho. A sphere of radius R by 2 has a charge density of minus rho. And then we have to calculate electric field at A and B. Done. So चलो करके देखते हैं. अब question easy हो जाएगा. So EA if we have to calculate at A, electric field will be because of both bigger and smaller sphere. So point A is on the circumference of A. Done. So if we are going to see on the circumference of A, if point A is there, then electric field at point A because of this negative charge will be at A, will be in this direction because it has negative charge density. So towards the radius in this direction. Done. And how much value? If it has a charge Q dash, then we will say Q dash negative charge KQ dash by R square. Now Q dash value will be how much? Like suppose कर लो कि bigger sphere has a positive charge of Q. What will be the value of Q dash? Both has the same charge density but of opposite nature, right? So Q charge is there in a bigger sphere. Done. So Q is equal to how much? 4 by 3 pi R cube into rho. है ना? And Q dash is equal to how much? 4 by 3 pi R by 2 का whole cube into rho of negative nature. So magnitude wise if I compare, so Q by Q dash किसके बराबर दिख रहा है तुम्हें? Q dash is this will become 8. So Q dash is Q by 8. So here we can write KQ by sorry R by R square मैंने लिखा है, R by 2 का square होगा क्योंकि this is of radius R by 2. ठीक है. So KQ by 8 here you will write and R square into 4. So this will become equal to KQ by 2R square. ठीक है. Because of bigger sphere. EA because of which? because of a sphere of radius r by 2. Now EA because of a sphere of radius r will be equal to how much? This is at the center. This is at the center of bigger sphere. So at the center, electric field will be what? 0. So whole electric field EA will become equal to how much? KQ by 2R square. Now let's calculate electric field at point B. So EB, if we calculate because of bigger sphere, sorry, smaller sphere first. So B is outside point and it is at a distance of how much from the center? R by 2 plus R, 3R by 2. So KQ by 8 into 3R by 2 ka whole square. So if you are going to do this, KQ into 4 by 8 into 9. So this is equal to KQ by 18 R square. So this is equal to KQ by 18 R square. Now electric field at B because of a sphere of radius R will be equal to how much? This is on the circumference of a bigger sphere. So it will be equal to simply KQ by R square. Okay? And direction, just you be careful of the direction. This is because of negative charge distribution. So at B, electric field will be because of a smaller sphere in this direction, because of bigger sphere in this direction. So we need to subtract these two. So this is bigger one, subtract this to this one. So E net, EB net kitna hoga tumhara? It will be KQ by R square minus KQ by 18 R square. So this is equal to 17 KQ by 18 R square. Now we have to take the ratios. So EA by EB आपको करना है, and if you are gonna do EA by EB, what value you will get? KQ by R square देखो दोनों में ही common है, so I am just neglecting it. 1 by 2 into 17 into 18. So this is equal to 9 by 17. So X will be equal to how much? 9. Okay. So that is how we solve such question. Now let's do this question. There is a square wire and that is framed. Initially current is 0, side A and long straight conductor carrying a constant current I are located in the same plane. The resistance of the frame given is respectively. Frame is R respectively. The frame was turned to 180 degree about the axis OO dash. So around this it is moving. And initially this B is equal to what? Initially before rotation it is equal to 2A. The total electric charge flown through the frame if I is equal to 0 at t equal to 0 in the loop is equal to this. Yani ki initially current through the loop is 0, but when we will move it, flux through it will change, and because of that some charge will flow in the loop. We have to calculate how much charge is flown. So charge flown through any loop because of flux change, how we write that? Charge flown is equal to flux change by resistance. This is the formula, right? This is the formula and this is coming from where? EMF equal to minus d5 by dt से ही आया है, क्योंकि EMF को IR लिख सकते हो, I को dq by dt लिख सकते हो. From where there we are getting this formula. So trying task here is to calculate delta phi. So let's see. Initially our loop is like this, and final loop position is what? This dotted position. It has traveled through 180 degree. So what is the initial flux through the loop and what is the final flux? And then flux difference we can calculate. So initially flux is how much through this loop when it is in this configuration. So area of loop if we area of loop is normal to the plane. So normal to the plane, if I am considering for now normal to the plane as outward, then area vector is outward, magnetic field is inward because of current carrying wire. So between area vector and between magnetic field, how much is the angle? 180 degree. Okay. So if angle is 180 degree, flux we will calculate as flux equal to B dot A. But here what the thing is? Thing is that magnetic field won't remain constant at every point of the coil because this wire distance for different element of coil is different. So magnetic field because of a straight current carrying wire का formula क्या होता है? Mu naught I by 2 pi r. And here distance of this coil from the wire is different for different points. And so magnetic field is not constant throughout. So we need to calculate flux by doing integration. तो एक काम करते हैं, कोई भी एक small strip लेते हैं. Suppose this is at a distance x from the wire. So at this point, magnetic field will be how much? Mu naught I by 2 pi x. ठीक है, इसका एरिया निकाल लो आप. इसका एरिया विल बी, दिस इज ए एंड दिस width is dx, suppose, so area is a dx. So d phi, if I calculate, it will be equal to b mu naught I by 2 pi x into area, that is dx into a. ठीक है, an angle that is cos 180, so -1. Then this is d phi. Now total flux in this configuration will be, इसको integrate कर दो आप. So phi will be equal to minus of mu naught I by 2 pi ln x. dx by x का integration क्या लिखोगे? ln x. And x will vary from here to here to cover the whole loop. So here means this whole is 2a and this is a. So this distance will become a. So x is varying from a to 2a. So this is a to 2a. And ln 2a minus ln a, that is ln 2a by a, that is ln 2. So minus mu naught I by 2 pi ln 2. This is the initial flux. What will be the final flux? Final flux, if you go on to write, so be careful. Final flux you will write as what? Finally, configuration is this. So finally, if it has rotated by 180 degree, it's what? It's area vector will also rotate by 180 degree. So initially I consider area vector in this direction. Finally area vector will go in this direction into the plane. ठीक है, तो 180 degree से area vector भी rotate कर गया, but magnetic field is still same. So now angle between B and A will become 0 degree. Done. अब इसके लिए आप कैलकुलेट करो. अगर आप सेकेंड पोर्शन के लिए कैलकुलेट करोगे तो कैसा दिखेगा? सेकेंड पोर्शन मतलब सेकेंड सिचुएशन के लिए, यानी कि सेकेंड सिचुएशन में मेरा जो रॉड है वो कैसा है? ये डॉटेड जैसा है. अब इसका कोई भी एक एलिमेंट ले लो. ठीक है, अगेन एक्स डिस्टेंस पे आप ले लो. ठीक है, इसका विथ dx ले लो. डन. और ये इसका लिमिट कहाँ से कहाँ चेंज होगा? ये रेक्टेंगुलर स्लैब और कॉइल अब यहाँ से स्टार्ट हो रहा है और यहाँ पे एंड कर रहा है. तो ये डिस्टेंस कितना है तुम्हारा? ये डिस्टेंस है 2a and this whole distance will become 3a. So limit will be from 2a to 3a. Calculation will be same. So mu naught I by 2 pi ln x. लिमिट क्या होगा? लिमिट होगा तुम्हारा 3a से, सॉरी 2a से 3a. So that is equal to how much? Final flux is equal to mu naught I by 2 pi ln 3 by 2. Now what is the change in flux? Final minus initial. So आप दोनों को ऐड कर दोगे, कितना होगा? mu naught I by 2 pi ऐड कर दो ln 2 प्लस ln 3 by 2. ठीक है, ln a प्लस ln b क्या होता है? ln a इंटू b. a इंटू b अगर करोगे 2 इंटू 3 by 2, 3 बचेगा बस. So mu naught I by 2 pi ln 3. This is delta phi. So charge क्या होगा? This divided by r. So x का वैल्यू क्या है तुम्हारा? x का वैल्यू है 3. So correct answer will be what? 3. ठीक है. Now let's do this question. There is a compound microscope. It has an eyepiece of focal length 10 centimeter, objective of focal length 4 centimeter. So focal length of eyepiece is how much? 10 centimeter. And focal length of objective is how much? 4 centimeter. ठीक है. Object distance is given, u is given from the objective, that is 5 centimeters. So if this is the objective length, this is eyepiece, then object initially is at a distance of 5 centimeters. And final image is getting formed at less distance of distinct vision. So what will be the magnification? ठीक है, what is asked? तो कैलकुलेट द मैग्निफिकेशन. ठीक है, तो मैग्निफिकेशन हम कैसे निकालते हैं? मैग्निफिकेशन जब लिखना होता है, सॉरी, ओके आई डिडंट गेट द कर्सर, सॉरी. सो मैग्निफिकेशन हम कैसे लिखते हैं? मैग्निफिकेशन बाय ऑब्जेक्टिव इनटू मैग्निफिकेशन बाय आईपीस. सो आईपीस इज forming image finally at least distance of distinct vision. It means ME will be equal to 1 plus D by FE. That is known by formula. ठीक है, and M naught we generally need to calculate. Then while we put the formula this m naught into me, me is known most often, like when it is given, final image is getting formed at less distance of distinct vision, me is 1 plus dy f. If final image is getting formed at infinity, me is dy f. M naught we need to calculate, so this will be equal to v by u. So for objective, if u is 5 centimeter, we need to calculate. So 1 by v minus 1 by u is equal to 1 by f. 1 by v minus 1 by minus 5 equal to convex lens, focal length positive, objective 1 by 4. 1 by v, 1 by 4 minus 1 by 5, and this is equal to 1 by 20. So v equal to 20. अब आप यहाँ पे देखो, this is 20, this is by minus 5, ठीक है, इक्वल टू 1 प्लस डी का वैल्यू जनरली 25 होता है, बट जो क्वेश्चन में दिया है अगर तो आप वो लो 1 प्लस 20 बाई एफ इज हाउ मच, एफ ई इज योर 10, सो दिस इज 3, ठीक है, so 4 into 3 that is minus 12, so answer will be equal to how much? In magnitude it will be plus 12, but if we take it with proper sign it will be minus 12, ठीक है, okay, चलो, so magnitude is 12. Now velocity of sound in an air, यहाँ पे देखो air is missing, ठीक है, in an air is 330 meter per second. For a particular sound in air, path difference is 40 centimeter, and this path difference is equivalent to this. यानी कि for path difference 40 centimeter, phase difference is how much? 1.65. ठीक है. The frequency of the wave is, frequency of wave we calculate like what? Velocity by wavelength. तो वेवलेंथ यहाँ से निकालने की कोशिश करते हैं. अब देखो, तुम लोगों ने एक टर्म पढ़ा होगा 2 पाई बाई लैम्डा. So this is your kind of wave number kind of thing. And if we multiply length by this, we can convert it into phase and difference. So if 2 pi by lambda into delta x हम करेंगे, then we will get delta phi. ठीक है. So 2 pi by lambda into delta x, that is 40 centimeter, is equal to how much? 1.65. Because it is given that 40 centimeter length is equivalent to 1.65. So convert 40 centimeter into angle, and that will be equal to 1.65. And that is what I have done here. So pi will get cancelled, and here this is 10, and this will become 4 times this will go by, this is 2. So how much value of what was that? Lambda. Lambda will go that side. So this is equal to 5. है ना? This is equal to 5. अब आप frequency निकाल लो. So velocity is equal to how much? 330, and 330 by, okay, I have done it correctly, right? Formula तो गलत नहीं हुआ ना? Just see it carefully. This is centimeter. Okay, 40 centimeter ko we need to convert into meter. 10 to the power minus 2. Okay, so if you are going to calculate lambda, 5 into 10 to the power minus 2. ठीक है. So frequency 330 by wavelength 5 into 10 to the power minus 2, and this will be 66. So 40 centimeter 10 to the power minus 2 I have done here. 1.610. This 10 will go here. Okay, we need to see it carefully. Calculation में कुछ mistake है. So 2 pi by lambda आप लिखो यहाँ पे. Delta x को लिखो 40 centimeter. So that will become 0.4 meter. So यहाँ पे 4 by 10 आप लिख लो. Equal to 1.65. That is 16 by 10 pi. So 10 will get cancelled. 4 this way, and this is 2. ठीक है. So pi will get cancelled, and lambda is equal to 1 by 2. ठीक है. यहाँ पे हमने क्या किया था? Calculation mistake किया. ठीक है. So this is not correct. Now simply write the thing. ठीक है. इसको भी हटा लेने दो. So 330 by क्या करोगे? Wavelength. So that is equal to 1 by 2. So this is 660 hertz. Over. चलो ठीक. So simple था. Now let's see this question. There is an ideal gas, and that is taken through ABCA as shown in the figure. If the net heat supplied to the gas in cycle is 5 joule, Work done by gas in the process CA is minus x joule. Find the value of x. Okay. So if we consider this cyclic process CBAC, then in cyclic process, change in internal energy क्या होता है? Zero. So if we apply thermodynamics first law, that is Q, heat given or taken out of the system, delta Q, will be equal to delta U plus work done. And this is zero. So delta Q will be equal to how much? Work done. Now, work done in process CA, total work done means work done in process CA plus work done in process AB plus work done in process BC will be equal to heat. Heat being given to the process similarly CA plus to the process AB plus to the process BC. Now put the values. Okay. CA process is what? We have to work done by gas in process CA निकालना है. So this we don't know. Work done in CA. Now work done in AB. AB is happening at constant pressure. Volume is changing from 2 to 1. Okay. So work done will be equal to 10 into pressure into change in volume PdV. Pressure is constant, so work done PdV, and 2 minus 1, that is 1. Now work done in B and C at constant volume, this is 0. Now now just see which process is which here. So work done by gas in the process C to A we have to calculate. Okay. And if the net heat supplied to the gas in the cycle is 5 joule. Okay. So this whole is given. Done. This whole is 5 joule. So no need of breaking it. Done. So work done in C to A will be equal to how much? 5 minus 10. So this is minus 5 joule. So X value is how much? 5. Over. Okay, so in this question, what we need to do is air is filled at 60 degrees centigrade in an open vessel of open mouth. So here what is happening? This is the bottle. Okay, open mouth means it is open to the atmosphere. So pressure inside will be equal to atmospheric pressure. It has certain volume V. Now what is happening? Initial temperature is 60 degrees. So in Kelvin, if we convert it, it will become 273 plus 60, and that is 333 Kelvin. Okay. And suppose it has N1 mole. Now what is happening? We are heating it, and because of heating, some gas is escaping. How much? 1/4. So finally in the container, how much mole will remain? 3/4 N1. Okay. And since it is open to the atmosphere, if pressure is going to be PATM itself, volume will remain the same because gas will occupy the volume of container, and that volume is not changing. So we done. And we have to calculate temperature of the second container. Okay. So up to what temperature we have heated it, that we have to calculate. So if we apply PV equal to nRT, you can see here PV by R will remain constant. NT, it will remain constant. Pressure is same in both, volume is same in both, R is a constant. So N1 T1 will be equal to N2 T2. It is as simple as this. Okay. And if you're going to write N1 value is how much? It is N1. Say T1 is how much? 333. N2 is 3/4. So this is 3/4 N1. Okay. So N1 will get cancelled. And this is T1. This will become 111. So T2 is equal to 444 Kelvin. Degree centigrade we have to answer. So 444 minus 273. So it will become equal to 273 if you're going to subtract 1, 7 and 1. So 171 degree centigrade. Okay. Now let's do this question. The process form a thermodynamic cycle as shown in PV diagram for an ideal gas. Process 1 and 2 takes place at constant temperature. So this is an isothermal process. And temperature here is 300 Kelvin. 2, 3 takes place at constant volume. So this is isochoric. Done. And process 3, 1 is adiabatic. This is adiabatic. Okay. And temperature T3 is given. T3 is 275 Kelvin. Its temperature. Work done by gas during 3 to 1 is x joule. Find the value of x. Again, this is a cyclic process. We can apply the same approach like first law of thermodynamics अगर आप apply करोगे तो change in heat released or added whatever delta Q will be equal to work done by all in whole the processes, because delta U will become here 0 because this is a cyclic process. Okay, so delta Q, if I talk about Q12 plus Q23 plus Q31 to 0 hoga because this is the adiabatic process. So this is 0. Now work done in 1-2, work done in 1-2 plus work done in 2-3. Volume is same, so this will 0. And work done in the process 3-1. This we have to calculate, right? So now let's see, heat given out in process 1 and 2 will be equal to how much? So during this process, 100 joule of heat leaves the system. Process 2-3. So in process 2-3, 100 joule of heat leaves the system. So this will become minus 100 joule. This will become how much? Minus 100 joule. And now if you see the process 1 and 2, this is an isothermal process. So in this process, what will happen? If you consider process 1 and 2, and for 1 and 2, if we apply first law of thermodynamics, so Q1 and 2 will be equal to work done in 1 and 2 plus delta U. And since this is an isothermal process, in 1 and 2, delta U will be 0. Temperature is remaining same. So Q12 is equal to W12. So this is equal to this. Now, if you calculate what value you are getting, W31 is equal to how much? This is equal to W31 we have to calculate. So that is, and 2 heat leaves the system. Okay, heat leaving the system. When we add heat to the system, that is taken as positive. Okay, that is why I've written here negative. But if you consider work done in true sense, its magnitude will be how much? 100 joule. Done. But in the answer, it was given 40 joule because, and that will be only true if this value in the question is given as 40 joule. Okay, so whatever answer were given to us was not correct. Okay, so next. Next and last question. So steam at 100 degrees added slowly to 1400 gram of water. 1400 gram of water is here. And this water is at 16 degrees. What is happening? The steam is getting passed through it. And until its temperature is rising to 80 degrees. Okay? The mass of steam required to do this. Now, if its temperature is rising from 16 to 80 degrees, how much heat it requires? So heat required is equal to mass of water in the tank into specific heat of water into delta T, that is your 80 minus 60. This much heat it requires. And that heat will get given by steam. A steam is at 100 degrees. So suppose karo m mass of a steam is condensing to is basically getting converted into water to heat this 1400 gram of water. It means if m gram of a steam is helping it happen, then m gram of a steam will first get converted into 100 gram, sorry, will get converted into m gram of a steam ko maine liya hai. So it will first get converted into m gram water at 100 degree, and then it will get converted into m gram of water at 80 degree, because finally system is at 80 degree. So whatever steam is going into this water will also be at 80 degree. So this much heat it will release. Now in this process, how much heat will come out? M LV, and in this process, M into a specific heat of water into temperature difference, that is 20 degree. So this plus this is going to be equal to this. Now let's put the values. Mass of a steam M, LV is 540 plus 20 M, and this will be equal to 1400 gram specific heat of water, that used to be 1. So 18 minus 16, so this is 4, and this will become 64. Okay, so this is your 560 M. Done. 560 M, and this is equal to 1400 into 64. If you're going to cut it, you will get, या फिर इसको कट करके देख ही लेते हैं, 64, and this is by 56 into 0. So this will go 4 times, and This will go 16 by 16 times, and here this is 160 grams. So this will be your answer. I hope you have understood all the solutions that I discussed. And still, if you're having doubt in any other question, you can let me know through whatever sources available to you, through whoever person is from our team in contact with you. You just let them know that you're having doubt in such questions. I will be sending you the solution for sure. It's not just a mandatory thing to say in the last. It is something that I really mean. So yeah, and stay prepared for your next test. Stay healthy, stay happy, keep working. Bye bye. Take care.